Welcome back to this RET1 course and the block of solar fundamental lectures. This is part 2 of my first block, and I will mainly focus on solar time or time in solar calculations. My name is Rafael Guedez, and I belong to the CSP group at KTH Energy Department. Now, when performing solar power plant design or any calculations regarding solar, it's important to know that there is a difference between the clock time and the solar time. And the one we use for solar power calculations that's called solar time, which can be defined as, or defines the noon or 12 as the moment when the sun is exactly due south at the local position of the observer. Whereas clock time defines noon as the moment when the sun is due south for an observer on the local standard time zone meridian. Now, the relation between these two is easy to calculate by one expression that is here shown in this slide. So solar time is just the clock time, but some addition to correction factors. One, regarding the difference between the actual position and the standard meridian. One, which is called the equation of time. This is what I will explain further in the next slide, but basically it's a correction for all the elliptical movement of the Earth. And one that is easy to understand, that is just the daylight saving time, that is when the clock is moved forward during the summer. Then all the parameters to calculate them is important to know, and are easy to know based on the location of where the user is and the clock time. Moving on to these correction factors independently, then it's important to know, as I said, the first correction depends on the clock time zone. So wherever you are, there is a clock time and a solar local time, and the clock time will depend on the meridians or longitudes. So it's important to know for each location which is the reference meridian used for clock calculations. And here you can see how for Central Eastern Europe, for instance, we have one which is different from that one in the UK and so on. Then the correction of equation of time, it's basically due to the elliptical nature of the Earth's orbit, and the speed of rotation around the sun is not constant, but it varies throughout the year. And then to correct this factor, then basically we can see from in this figure, and also its correlation in the equation of time calculation, how for every day we can estimate the actual correction factor based on some coefficients that are here depicted and that we measure empirically. The last correction factor to take into account is the daylight saving time. And the daylight saving time is the practice that we have that during summer we advance clocks, so that evenings have more daylight and mornings have less. And this means that solar time is 1 hour behind the clock during daylight saving time. This is not used throughout all the world, but it's important to know if you're performing calculations, whereas if it's summer, and if this is applicable. So here in this figure you can see where is it used, where was it used before, and where it has never been used. Important to notice that big part of the Western world and where some of the solar calculations are performed do use daylight savings time. Now, to put this into practice, we can have a very simple example, and in which, by knowing the clock time, then we are asked what's the solar time. So if it is 15:45 on the clock in Stockholm, and then that means that we can get access to the actual location of Stockholm on the 26th of July, which can correlate to a specific day of the year, then what is the local solar time? So the first thing to note is that which is the actual standard time zone meridian for Stockholm. And you will notice that Stockholm uses Central European time if you search for it, which means then the standard time zone meridian is 15 degrees east. Also, the question here is performed for a day in the summer. So daylight savings time is affecting summer. So the first thing is we need to calculate these correction factors. So the first correction factor and the easiest to calculate is the equation of time, which is just replacing the coefficients and for the specific day 207. And that will yield a difference of minus 6.5 minutes. Then the daily saving time, which is minus 1 hour, because we are behind the clock. And the last correction is just between the actual longitude and the standard meridian used for the time, which is important to notice again that it's made on west. So that's why the minus here on both minus 15 and minus 18. With these correction factors, by replacing them, then we just are able to calculate that the solar time for that specific clock time on that day in Stockholm is 14:50. So we are more than 1 hour behind when it compares to clock time. So this was the last part of the solar fundamentals concerning time in solar calculations. My colleague Lucas Zachmeyer will continue in solar fundamentals talking about how to position the sun and some important notice when it comes to solar radiation on flat surfaces. Thank you.